Hello students, and welcome to another video. I'm your teacher, Mr. Flynn, and today we're going to be focusing on how to determine the empirical formula and molecular formula of compounds that we're working with, okay? Now, in this first example with empirical formulas on the left, all right, we're going to look at our example here, and we need to calculate the empirical formula of a compound that is 94% oxygen and 6% hydrogen. So basically, we want to come up with a formula for us to work with. We don't know how many oxygens there are, we don't know how many hydrogens there are in this example, but we do know that oxygen is more massive, but it should take up most of the mass, but we don't know how many oxygens there are to hydrogens. So the first thing you do is you need to assume that there's 100 grams. So there's 100 grams, and that is an assumption that we're going to make this calculation, okay? Because 94 plus 6 is 100, 100%. Well, let's just assume that 100% is 100 grams, and let's work with that. So we're going to put this into a picket fence, and we're going to break it apart, okay, so that we can find our mole ratio. All right, so we have 94 grams of oxygen. We'll put that into our picket fence, and we need to convert it into moles. And if you've watched the previous videos, 1 mole of oxygen is equal to 16.00 grams, okay? All right, we have that set up, and let's do the second one. The second one is 6.0 grams of hydrogen, and now we need to convert this into moles, and this is 1 mole of hydrogen is equal to 1.008 grams of hydrogen. So when we calculate this out, okay, we end up with a total of 5.88 moles of oxygen, and this one comes out to be 5.95 moles of hydrogen. And what we're going to do now is divide by the smallest amount. So you're going to divide by the smaller amount. Okay, so our mole ratio for hydrogen is, we have 5.95 moles of hydrogen, and we're going to divide that by 5.88 moles of oxygen. And then our mole ratio for oxygen is 5.88 moles. Oxygen, actually I shouldn't, it's all right. We're just doing a direct comparison. That's all we're doing. And then 5.88 moles of oxygen. So what we're going to do is divide these. So this bottom one is basically 1. So 5.88 divided by 5.88 is 1. And then the next one up here is 1.01. And that's very, very close to 1. Okay? So what we're doing is we're trying to find a comparison. And if you look at this comparison, it ends up being a 1-to-1 ratio. So when we write this, the empirical formula is just OH, because when we do the math, right, it ends up coming as 1-to-1. So let's just say, for example, this ends up being, let me just do a little math here and come up with an example. Let's just say our mole ratio of hydrogen was, instead of 5.99, it was 11.76. That means it would come out to be 2. Right, so now it's 2-to-1. So then that would be 2 hydrogens for every oxygen. Okay, so the idea here, okay, I'm not trying to confuse you too much, is that you're trying to compare the molar amounts of both oxygen and hydrogen, and then you're going to see how they compare to each other. All right, and you're going to get plenty of practice with this. I have a lot of practice problems, and they're a little trickier than this one. This one's pretty simple. It's just 1-to-1. But as you work through it, you may actually have to do an additional step to calculate it, and I'll have some additional videos for that as well, okay? But the idea here is you're calculating how many oxygens and hydrogens there are based on the percentage, okay? All right, the second one here, the molecular formula, this one's a lot easier, okay? And the reason is because it's giving you the molar mass amount, okay, so we know how much it weighs, and it's giving you how many carbons, hydrogens, and oxygens there are. Okay, so in this example, before it's just the percentages of each. Well, now it's giving you the mass, and it's telling you what the formula is. Okay, so what we're going to do is we need to do a little bit of a setup here. Okay, and we need to calculate what the molar mass of CH2O is. Okay, so CH 2O. So we have carbon is 12, hydrogen is 1 plus 16. Okay, if we do this math, it ends up coming out to be this. It ends up being 30.03 grams per mole. Okay, and then what we have to do is compare that to what the actual molar mass is. So 150.05 grams per mole. Okay, and then I'm going to divide that by 30.03 grams per mole. And you'll notice my units all cancel out from each other. Okay, and then I'm given if you look at 150 divided by 30, that gives us 5. So what we're seeing here is that CH2O is a multiple of 5 of that. So what we're really working with in the lab is not CH2O, it's actually C5H10O5. And the reason why we're doing this is because if you were to do the percentages like what we did before, I'm going to kind of draw an arrow to it again, okay? If it was 94%, 6%, etc., well, we don't know if we're working with C4H8O4. We don't know if it's C5H10O5. We don't know if it's CH2O because they all have the same percentages, right? They all have the same percentage of carbon. They all have the same percentage of hydrogen, the same percentage of oxygen. But what we do know is that the molar mass of what we're working with is 150. But because we know that, we can compare it to the molar mass of its most simplest form, which is CH2O, and then find the multiple of it. And the multiple is 5. And so C5H10O5 is what we're working with in the lab. Okay? All right. If you have questions about this, please come talk to me, and I can help work through any of the kinks that you're stuck on. Okay? Thanks again, and until next time.